In this video, you will learn how to write numbers using scientific notations. Why, Ms. Ramos? Why are we doing this? Because some of you were skipping your 8th grade math class, and it's in that class in which you learn how to write big and small numbers using scientific notation. In addition to learn how to write numbers using scientific notation, in this video you will also learn how to perform mathematical operation with numbers that are written in scientific notation. Why scientific notation? Okay, and as you can see over here, I have put over here the definition of scientific notation. And scientific notation can be used to express any number as number between 1 and 10 multiplied by 10 raised to a power. But why or when do we use scientific notation? We use scientific notation when we are working with numbers that are too big or numbers that are too small. Usually in chemistry, you're going to be working with numbers that are too small because we're talking about very small amount of substance and that are involved in a chemical reaction. Now in physics, you're going to be working with numbers that are too big, especially when you're talking about the distance between different planets. So it doesn't matter if you are working with numbers that are too big or are too small. Scientific notation can be used to write them in a way that is gonna be easy for you to perform calculations using your calculator. Cause I'm pretty sure that you're not gonna be able to enter this number in your scientific calculator. It's not gonna accept that number. It's gonna give you an error. Okay, so how are you gonna write this big number using scientific notation? First, I have to clarify that when you're writing a big number using scientific notation, the exponent, and you have that over here, see, exponent is gonna be positive for big numbers. But when you're talking about small numbers, small like the mass of one carbon atom, see, the exponent is gonna be negative when you're talking about small numbers. Keeping that in mind, what's gonna happen over here when you have this big number over here? The exponent is gonna be positive. Miramos one more time. What is gonna be that exponent in the power of 10? So you have to remember that when you have a whole number, the decimal is at the end. You have to move the decimal point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 places to the left, meaning that you're gonna multiply that by 10 to the 17 positive because it's a big number, and since you have to write that number, see, as a number between 1 and 10, you're gonna stop over here in the one place, 3.62. So this big number, which is written in the standard form, is writing like this in scientific notation. 17 positive because you are moving the decimal to the left 17 places, 3.62 because you stop over here. That means that if you want to rewrite this in the standard form, you will move, see, the decimal point to the right as many places as the number that you have in your power of 10. And the same is gonna happen with the second one. Now, what happened with this one? See that? Let me put a decimal point over here because let me put the decimal point here. See, it's a number extremely small. You try to put this in your calculator, you're not gonna be able to do that. Like last year, I remember that one of my students in physical science was trying to put a very small number inside the calculator, and the calculator was giving him error all the time because the number was too small. In that case, what do you have to do? You have to write the number in scientific notation and then continue with the calculation. In this case, you know that the exponent that you will put over there will be negative. Why? Because you have a number that is too small. But what is the number, Ms. Ramos, that I'm going to put over there? Okay, you're going to start moving your decimal point. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to stop over there because I'm going to stop in the one place. So negative 12, since I'm putting the decimal point over there after the one place, this is the way that I'm going to write this small number using scientific notation. It's super easy. You look for the decimal point. Just keep in mind that when you have a whole number, the decimal point is at the end of the number is written in standard form. You move that, see? You have to move. And this is a generalization. I don't want you to memorize that. I want you to analyze that. If you have to move the decimal point all the way through the left, the exponent is gonna be positive because that means that the number was too big. But if you have to move the decimal point all the way through the right, the exponent is gonna be negative because that means that the number was too small. When you are adding and subtracting numbers that are written in scientific notation, you have to make sure that the exponent in the power of 10 is the same. So in this case, see, since the power in the exponent in the power of 10 is the same, you don't have any problem with that. You will proceed to add the numbers, just making sure that you are aligning the decimal point, and then you add your numbers. So 5.75 times 10 to the negative 5. See? Without a problem, because as you can see, the power of 10 is the same. In this case, same. You're going to proceed the same. Why? Because the exponent in the power of 10 is the same. Now, the only problem over here is that you will have a negative number because 7.30, negative 7.30 has like a higher absolute value times 10 to the 9. Okay, so that's your first step when you are working with numbers written in scientific notation. So if you are adding or subtracting, you have to look at the exponent in the power of 10. The exponent in the power of 10 is the same. You are to subtract the numbers, and then you will keep the same power of 10 in your final expression. Now over here we have a problem. We are adding the numbers, but they don't have the same exponent in the power of 10. So in problems like this, see, my recommendation is just to analyze. 10 to the negative 5 is bigger than 10 to the negative 7. So in this case, I would recommend to convert this 10 to the negative 5 into 10 to the negative 7. But you don't have to follow my advice. You want to convert the 10 to the negative 7 in 10 to the negative 5 is the same. At the end, you will have the same results. For this example, I'm going to show both approach. But I'm going to start over here with 10 to the negative 5. Okay? So I need, see, in order to have over here 10 to the negative 7, I need a negative 2. What the negative means, that I'm going to move, I was explaining that on the slide before. I'm going to move my decimal point 2 places to the right, times 10 to the negative 7. See, that negative 2 that I was needed there in my exponent in order to get a negative 7, that negative means that I have to move my decimal point 2 places to the right. Plus 1.25 times 10 to the negative 7. And as you can see right now, I have the same exponent. You're going to proceed, you were proceeding on the example before, just making sure that you are aligning, okay, the decimal point. 5, 2, 1, 5, 4. And the answer will be 0.25 times to the negative 7. Okay, that would be your answer. That you can rewrite. You can rewrite. You want to rewrite that, you can rewrite that as 4.5125 times, okay, to the negative 5. See, I was moving the decimal point 2 places to the left, and then I was adding a 2 over there. Okay, just keep that in mind. But if you leave it like that, like, see, in this, see, if you leave your answer like this, that would be fine too. Over here, the only thing that I was doing was just rewriting my expression. Now, the next approach, no, the next, the other possibility, not the next approach, the other possibility, just to keep this as 5, 4.5 times to the negative 5. And now I have to convert my negative 7 in a negative 5. In order to do that, I have to add 2 to my exponent, because negative 7 plus 2, that's going to be equal to negative 5. That positive 2 is translated into, okay, moving. Positive means that I'm gonna move to the left. How many places? 2. Okay, 0.0125 times to the negative 5. See that? If once that you have both exponents that are the same, you are gonna proceed accordingly, okay, making sure that you are aligning the decimal point. So 5.215, my decimal point, 4.5125 times to the negative 5. And as you can see, you're gonna be able to obtain the same result. Over here it was 451.25 times to the negative 7 that I was rewriting. But over here, see, since you were using negative 5 as the exponent in u power of 10, the answer was 4.51. At the end, as you can see, is the same answer, just using different exponent in the power of 10. So I don't want to make generalization because I want you to analyze. But see, if you're going from negative 5 to negative 7, negative 7, negative 7 is smaller than negative 5. In order to go from negative 5 to negative 7, you have to subtract 2. See, same sign, and then you add them. That negative means that you're gonna move your decimal point in your number. See, the decimal point to the right. See, over here, when I was using, or when, see, we were using we were using a different approach. Instead of having negative 7, okay, we were converting the negative 7 into negative 5. In order to do that, you have to add 2 to your negative 7. If that positive is translated into moving the decimal point instead of moving the decimal point to the right, to moving the decimal point to the left. Okay? So, we're gonna practice one more time because here we have another example. Okay, so when you're solving problem like this, you know that your first step is just to look at the exponent. If the exponents, they are not the same, okay, you have to make sure that both power of 10, they have the same exponent. That's your first step. One more time, we are gonna use in this example the two variations, okay? I'm gonna start with the first one. So on the first one, this is an I. I want to convert that into an 11, so I have to add 2. So in order to write this number multiplied by a power of 10 to the 11th, raised to the 11th power, that 2 is translated into moving my decimal point to the left. How many places? 2 places. So 0.0784 minus 4.23. Once that the power of 10 is the same, you can use a calculator. Or piece of paper, just making sure that you are aligning 784, the decimal point, then you're subtracting 6151, and the answer is gonna be equal to negative 416 times 10 to the 11th power. And I'm pretty sure that you're understanding that. See over here, the sign of the one with the highest absolute value, and you're done there. See that? You're done because, okay, you were converting, or you just were writing the power of 10 with the same exponent. Okay, next approach, okay, or the other way that you can make this is just to leave the 9 over here, minus, now you have to convert this 11 into, this 11 into an I. So you have to subtract 2. If that negative number is gonna be translated into moving the decimal point negative 2 places, because you have a 2 places to the right, times 10 to the 9. See, you already adjust the exponent in the power of 10. What is your next step? Just to set up, or you can use, remember, you can use a calculator, or you set up, you set your numbers in a piece of paper, and you do that by hand. 6 1 5 1. Okay, so the answer in this case would be negative 415.16 times 10 to the 9th power. If you want to rewrite this, you can do that. Okay, so let's say that you want to move the decimal point 2 places to the left. Okay, if you're moving that 2 places to the left, you are adding a 2 to the 9, so it will be negative and as you can see over here, that's the same answer that you have over there. See, 4 or negative 4.1516 times 10 to the 11 is the same as negative 415.16 0.16 times 10 to the 9 power, or to the power of 9. Now, what happens when you are multiplying and you are dividing numbers that are written in scientific notation? Do you have to analyze the exponent that you have in the power of 10? The answer is no. Okay, because when you were in 7th grade, you were learning how to work with exponent. And you know that when you are dividing numbers that are written with exponent, when you have the same base, if you are multiplying, then you're gonna add the exponent. But if you are dividing, you're gonna subtract the exponent. And that's what we're gonna do in this example that we have over here. In this example that we have over here, we have two numbers that are written in scientific notation, but you are multiplying them. Okay, so do you have to worry about the exponent that they have in the power of 10? As I was telling you before, the answer is no. How are you gonna solve these problems? You're gonna multiply the numbers. In that last time that I was checking, 4.5 multiplied by 2, that's 9. And then you're gonna analyze your power of 10. Okay, so times 10, same base, I have to add the exponent. So -4 plus -3, hopefully you know how to work with that. That's gonna be equal to -6. And that's the answer for that one. Now, for this one that you have over here, see, when you look at the exponent, they are different. But you don't have to worry about that because you are dividing. You are not adding or subtracting, you're dividing. So how are you gonna solve that? One more time. You're gonna divide. If you divide 6.3 by 9, the answer will be 0.7. You multiply that by your power of 10. Now, what's gonna happen to the exponent that you have in the power of 10? Since you are dividing, you have to subtract them. So it's 9 minus 4, which is equal to 10 to the 5th powered. Miramos, that's a decimal. That's not the way that you write a number using scientific notation. Because, see, when you were explaining the definition of scientific notation, it's a number from 1 to 10, and we don't have over here a number from 1 to 10. Can I leave my final answer like that? No, the answer is no, so you have to fix that. So now, you will move your decimal point, okay? You will move your decimal point all the way to the right, and when you are moving your decimal point all the way to the right, you are subtracting. How many places you're moving your decimal point? 1. So you are subtracting 1. So the final answer will be 7.0 times 10 to the 4. Okay? Okay, so here we have another example. See? One more time. Miss Ramos, do I have to worry about the exponent in the power of 10? No. Why not, Miss Ramos? Because you're dividing. So if you are multiplying or you're dividing, you don't have to worry about your exponent in the power of 10, because it doesn't matter the number that you have over there. You will add the numbers in case that you are multiplying. You subtract the numbers in case that you're dividing. So you don't have to, okay, to fix your numbers in there when you are multiplying or dividing. How you gonna solve a problem like this? Easy piece. Okay, one more time. You're gonna divide the numbers. Okay, in this case it's 0.72.9. 0.9. Let me check on my calculator, but I think that is 0.9 because 9 multiplied by 8 is 72. Yes. 7.20 lo divide by 8. 0.9. 0.9 multiplied by my power of 10. Since I'm dividing, I have to subtract these two numbers. So it's going to be -4 minus -4. This case, 0.9 times 10, -4, negative becomes +4. They cancel, and I have over here 0.9 times 10 to the 0, which is equal to 1. Is 0.9 times 1 equal to 0.9. This is your final answer. Oh, Miss Ramos, but I don't have the answer in scientific notation. How can I write that on scientific notation? Okay, so you're going to move your decimal point to the right one more time, and since you're moving that to the right one more time, you're going to subtract. Okay, how many places you're moving that? 1. So you're going to subtract 1. So if you want to write the number using scientific notation, the answer will be 9.0 times 10 to the -1. It's super important to understand when you're working with numbers that are written in scientific notation that you look at the exponent that they have in the power of 10. Just keep in mind that when you are adding and subtracting, the exponent in the power of 10 has to be the same. If you have different exponent, then I was explaining on the video how to move the decimal point in order to fix the exponent in the power of 10. Now, when you are dividing or you are multiplying, you don't need to worry about that. Keep in mind that when you are multiplying, you have to add the exponent in the power of 10, and when you are dividing, you have to subtract them. Pay special attention to the signs, especially when you are dividing. Remember that you have to subtract, but if you have a negative exponent in your denominator, then that will affect the outcome. Okay? Just one more time, just go over all the problems, and if you have any questions, just send me a message.